So I work in the field of extreme electrochemistry. That's what I've dubbed it. And this is electrochemistry in liquids at elevated temperature. So it's non-aqueous. I don't do electrochemistry in water. So these are high temperature liquids, molten salts. For example, how aluminium is produced in molten fluoride, and even going to higher temperatures with Boston Metal. I invented the molten oxide electrolysis. So this is now operating at temperatures, white heat, 1600 degrees Celsius, and so on. And so there's an entire range of new chemistries that can facilitate the efficient extraction of metal from ore in ways that are much more advantageous than the conventional processes that rely, for the most part, heavily on carbon reduction. And so I reasoned years ago that the electron is the most efficient reducing agent. There's no carbon associated with the electron, unless, of course, you burn coal to make the electron. But if you generate the electrons without carbon, then you can convert ore into metal without any carbon emissions. And so that's been the focus of my research for about the last 40 years. So the mining sector has some big challenges, and many of them are outside my domain of expertise, and I have the humility to admit that I can't help them on those challenges. But I think that there are some challenges that can be met by consideration of downstream operations. I'd like to remind people that one cannot draw copper wire with copper ore. It's important to mine the mineral and get the ore out of the ground, but there has to be the conversion of ore to metal. And it is with the metal that one draws the copper wire. And so that's pretty much the situation with all the minerals. I don't know of too many minerals that are used in commerce as such. And so I think that with vertical integration, right from mine face to the final product in the device, whether it's the mobile phone or the computer or the automobile or the airplane, I think a consideration of the mine to the final product might reveal some ideas that are valuable in assisting the efficient use of minerals, reducing emissions to air, to water, to soil, and improving profitability. So the mining sector could benefit from new technologies in the emissions that are generated in the course of extracting the minerals. The heavy machinery is powered by hydrocarbons, and with the hydrocarbons come emissions, and especially if you're underground, then that places the burden of exhaust of the atmosphere. Otherwise, you're going to asphyxiate the workers and so on and so forth. So electrification of all that instrumentation could be advantageous just in the enterprise of breaking rock and getting it out of the ground. And then there are plenty of other efficiencies that can be attended to thanks to innovation. And that innovation is, in my opinion, borrowing from my knowledge of electrochemistry, applied electrochemistry, to try to electrify as much as one can, because the electron doesn't come with the attendant emission of harmful species to air, to water, to soil. So I think there's plenty of room there. Oh, I've seen a big change coming to FMF over just several years, that people are talking about innovation in ways that they weren't before. There is no question that I see the willingness to embrace change. I think it's driven in part by the realization that the richest ores have been depleted, and people have to figure out ways to get profitability out of ores of lower and lower concentration, and maybe using the same old processes is not going to get them there to the goal of profitability. And so that means there's a a pressure to innovate. And then, of course, when we think about deep decarbonization, that requires changes in how we practice what we've been doing in the past. And then pressure to look at things such as circular economy, recycling, and so on. So you can think of recycling as, is it urban mining? I mean, there are all sorts of new challenges that people face, and you can't use the old tools to address the new challenges. So I do see a willingness on the part of people from the mining industry. My aim in attending FMF and participating is to, I'm a professor, I'm an educator, but I'm a two-way device, not a one-way device. So I have some messaging that I would like to get out and invite people to think about things in ways that would be advantageous to them, to the extent that they want to appropriate these ideas, embrace these ideas. But I also want to learn, because I want to make sure that I'm asking the right questions. A brilliant answer to a poorly posed question is pointless. And so I learn a lot at FMF. And I learn in the span of several days what would take me years of reading and have to sort through what is real and what is not. FMF it's a crash course, so much information compressed into several days. And then, of course, the chance encounters in the corridors. I mean, I can read a fantastic article, but I can't speak to the writer. I suppose I could try to track down the person's email address and write them, but I might bump into that person in the corridor. And there's no substitute for that experience, that human interaction. And the other thing that happens at FMF is I go with the expectation of such and such, and then there's the surprise that I wasn't anticipating. And it's a Forrest Gump moment. I mean, nobody knew that this would happen. And the richness of that experience can only be had by being in person on the ground. You can Zoom all over the world, but you're getting the 2D representation. I prefer the 3D representation. The key message that I have is that I would invite people who are involved in mining to consider vertical integration downstream, to look at the conversion of ore into metal, which is the material that most builders are going to use with which to build the finished product. I mean, we don't build airplanes with aluminum ore. We don't draw copper wire with copper ore. We don't build mobile phones with ore. So I think there's plenty of room there for innovation, and it's a rich innovation, meaning that it is going to be profitable. And so I invite people in mining, don't leave money on the table when you're leaving the room. You know, you've got the stuff out of the ground, let's convert it to finished metal, and everybody wins. There's efficiency there. I mean, right now we ship ore to the smelter, but I wonder, could we site the smelter next to the mining site and then just ship the finished metal? I mean, there's so many other ways of thinking about the problem. And necessity is the mother of invention, and there are some needs, pressing needs that we're facing today. So let's innovate. Let's invent our way out of them.